Okay, let's take a look at what happens when we take zinc, the metal. We just used in the demonstration, and oh, okay. Well, let's fix that for you. All right, so I'm taking zinc, the metal, and I'm going to react that with, oh, let's see, how about silver? Let's see. Yeah, NO3. That'd be a good one, wouldn't it? Okay. So zinc is going to be, if it's a metal, it's going to be a solid. And we're going to make AgNO3 dissolved in water. We're going to call it aqueous. Well, this goes in your notes right now. Okay? You can't sit at a lab table. You got to stand. Really. So let's put that back where you got it. Was it there all along? Was the chair there? What are you sitting on? Are you on your knees? Oh, well, I guess you can go on your knees if you want to. That's fine. I thought you were sitting down on something. Okay. All right. How are we going to find out if this reaction will occur?
Balance it.
Well, we're not ready to balance it yet. We don't have any products. Got to use the activity series. All right. So how do we use the activity series? What do we need to do with that? Find a single element.
That looks like it.
Not looks like, but is like. Okay. Okay. Yeah. All right. All right. And what do you mean similar? What are we looking for that's similar to that? This element that's like by itself. Okay. So we were looking for the other metal here, right? Because metals can potentially displace other metals, all right, and hydrogen. Okay, we want to find out if the zinc will replace Ag. It is higher. If it's higher, then it can replace it. Okay, so zinc can go over here and kick out the silver and join up with the nitrate.
So you determined that it's higher because zinc had a 2+.
No, it's higher on the activity series. It's above it. So here's the activity series right here. And here is, let's see, zinc is right here. And not aluminum, silver. Silver's down here. So since zinc is above silver, zinc can replace or displace the silver. Okay? So over on the other side then, the other side of the arrow, the other side of the equation, then we want silver by itself because it just got displaced. Okay? So if I've got silver by itself, what physical state are we going to give that? Solid. Okay? Metals that are, except for mercury. Actually, there's one other metal we don't really deal with very much in here, but almost all metals are going to be solids. We're working with them at room temperature unless I give you some reason to know otherwise. And zinc is going to displace silver, and it's going to be chemically reactive with the nitrate. So we're going to put that together then in a compound. Okay? Zinc and nitrate. Okay? But I can't just leave it there. I've got to figure out whether that's balanced or not, and if it's not, I've got to balance it. So how do I balance this kind of a compound? You what now? No, we're not ready to do that. We do the AI chart. Oxidation numbers will tell you that. Okay?
So you got to do the oxidation chart.
Well, you got actually for this one you got to go to two different places. One place is the oxidation chart, or the periodic table with oxidation numbers. So it looks like this, and I can see that zinc has a 2+ charge. Okay, so zinc has a 2+ charge, all right? But I can't find nitrate on here. Nitrate's a polyatomic ion. Where do I find it?
Polyatomic chart.
Well, the common ions list is what it's called, but you're right. You could call it a polyatomic chart, I suppose. But the name of it is common ions, okay? And so nitrate, yes, indeed, is 1 negative. Let's see, where is that? There it is, right there. There's nitrate, 1 negative. Okay? NO3, 1 negative. So we've got a 2+ and a 1 negative. And we need this equation we've been using for 2 units, at least a month now. We've got to figure out what we put in these two empty places here to get a 0 charge overall.
-1 and positive 2.
Well, not a negative. It's just a number 1 and a number 2. So that means there's a number 1 in front of this and a number 2 in front of that. So to balance the equation, we need 2 nitrates, and the formula has the 2 following the nitrate formula.
Can you write a little bit darker? Because
I can't write any darker than a flare pen. I'm sorry. Okay. All right. Now we need to know if this compound is going to be solid or aqueous. Okay. Now we'll get to the solubility rules a little more later, but to find out if this is going to be soluble or aqueous, because we have this thing taking place in water, and we know that because at least one of the species is aqueous. That means there's water to dissolve it in, right? So we don't know that yet. What we're going to do is look at the activity series, the solubility rules here, which is right above your activity series, and we're going to look for either zinc or nitrate. Nitrate's the very first one, and it says that all nitrates are soluble. Soluble means they all dissolve in water. So what this will tell you is what it will do. This solubility rules will tell you what it will do. You have to figure out what it actually does. And to know whether it will dissolve means you have to look and see, okay, yeah, there's water. If there is water, it will dissolve. That makes sense? All right, so we're going to call this aqueous because this is taking place in water, and nitrates, according to this, will dissolve. Okay? All right, now we're ready to do the AI chart and balance the equation. Okay? So go ahead and do your AI chart. I'll do it up here, and we'll see how everybody did. Okay?
had they 30 as the second thing, the end of 30 and then 52, was that almost right there?
Yeah, well, no, when we balanced the formula it was. We had to balance the formula before we could go forward.
In fact, that's what you put in?
Yeah,
Okay,
you have to balance the formulas before you can balance the equation. You have to balance the formulas before you can balance the equation. Okay?